Hello, everyone. My name is Cliff Panos, a senior tech lead in iOS Club, and today our theme of the discussion is app development with Swift. So you can skip forward to whatever part of this is most useful to you. I'm going to start with some introductory concepts that might give you some good contextualization for how the Apple development stack works, as well as talk about Swift briefly, and the most interesting topic in Swift for newcomers, optionals in Swift. So we're going to start just by talking about the Apple development stack and overview. So we're gonna talk about what is Xcode, what are UIKit and Foundation, what are they really, what am I even doing, what is an iOS? We're gonna dive in. Okay, so these first topics about the development stack, we want to cover Apple platforms, talk about Xcode, coding languages, UIKit and frameworks, etc. So let's look at our platforms first. This is just to help define the term platform. There are really four, now five, maybe Apple platforms that we can write code and applications for, extensions, et cetera, et cetera. So those OS, iOS, and iPad OS as of iOS 13 era, and of course tvOS. And in this club, of course, we focus on um, just iOS and iPad OS. The good thing is for people who are new to this, if you're just getting started, you might think that iOS and iPad OS are completely separate OSs. At least for now, they are actually the exact same thing, just compiled, built, stripped and mastered and selected differently, such that, of course, the final result ends up different, right? So they might have slightly different build products on them, but for the most part, they're almost identical in terms of the OS itself, and it's just the code at runtime that uses device properties and capabilities to decide what to do based off of whether the device is an iPad or an iPhone to make it look and function differently. So that could be as simple as I have more screen area. Let's lay out the app differently to fill it. All the way to being as complicated as this iPhone has, I don't know, this piece of haptic feedback hardware that I can use in this way, right? So the point is, we're basically going to write a single app that's going to work on iOS and iPadOS because they are the same thing. And that's what we'll be doing, in iOS Club, app development, etc. So we do that with Xcode. Xcode is an integrated development environment IDE for developing Apple software, and I mean that really generically because it is pretty much anything that can run on Apple hardware is what you can build with Xcode. So it's more, you can build more things than just applications. There's such a thing as application extensions. You can build you know Apple compatible frameworks and libraries and executables and things like that. The list kind of goes on, but they have to be built in Xcode. You currently can't build any kind of iOS app and have it, correctly, be signed, installed, run, the normal route in anything except for Xcode on macOS. And that, of course, supports iOS, watchOS, tvOS, and macOS. Those are the types of applications and products you can build for those four platforms, operating systems. And that's why you should basically, whenever you're thinking about app development with Apple, you should just be thinking Xcode. That's the route. There's not another way to go. That's the single source of truth, if you will. So always start there and always keep your Xcode up to date. Xcode comes with the SDKs, these software development kits for these four platforms, as well as, that means all of the system frameworks that you might want to be using, which we're going to talk about. And Xcode comes with tools, really interesting metric capabilities, measurements, tools, debugging capabilities, everything that you'd want with a great IDE, and simulator, which is really useful, especially when you want to test, of course, how your code is going to look and feel on a device that you don't own physically. Because although Xcode will let you locally build and run an app on your device that you physically own over USB or even Wi-Fi debugging, if you don't have the brand new iPhone, you'll really want to see how that looks on the simulator before you're pushing out an update. One thing to keep in mind, though, is a limitation of this still is, from what I've been able to determine, checking with high confidence the performance of your app. So you might have you might be, let's say, debugging your brand new pretty app that's really complicated on your new iPhone 11 Pro, and it scrolls perfectly. And you want to check real quickly, oh, how does this work on, I don't know, the old iPhone 7 something screen size, right? So you might run that in simulator and it might look fine, but you won't really get a feel for if it's performing well, if you're hitting good scrolling frame rates, and unless you have an actual device for that. The simulator just currently, it doesn't quite cut it for exactly simulating, is that scrolling going to stutter or not? Just to keep in mind, bit of a side note. Okay, so UIKit is the framework that we've talked about tons in iOS Club, and you guys already know what this is. I'm just giving some background on how you should frame it in your minds, if you will. It is the primary infrastructure for your entire app. Every iOS app is a UIKit based application. Even the new Swift UI technologies are currently using UIKit concepts and the framework under the hood, because the system, you're on iOS and watchOS, all those, the core system components only know how to communicate with UIKit apps. So that is the framework that handles all incoming events. If you see here, it manages application lifecycle, event handling. That's the main thing that defines an application separate from just a pretty screen with pictures on it, right? Is it has events, it has user interaction. You're defining everything about the user interface. Handling, when I say the lifecycle, that means things like the application changing foreground background state, going from active to inactive states, handling things like rotations and trait collection changes, which means like maybe going from light mode to dark mode, right? These are all things that happen in like this dynamic application context. UIKit will even give you some support, at least at a top level, for even handling like motion events. It's really easy to handle a shake event to do shake to undo, even though that is coming from a bunch of underlying technologies and other frameworks. So it kind of is this top layer, really useful framework to do pretty much most of your, most or all of your common tasks. And it's going to provide some really great animation support, which is what makes iOS so great. Frameworks, you might be thinking, okay, well, what does that exactly mean? A framework is a bundle that has some kind of identifier and is going to contain the either the static or dynamic libraries with all of the code that makes them work, as well as other resources. So that's what separates a framework from something like just a dilib. Is it can contain other resources like storyboard files or images, asset catalogs, other things. You could have a bunch of random JSON files. You can think of it like a package, if you will. A framework is a wrapper for a bunch of code resources to make something awesome. So you could take, practically, you could take an entire app even, complete with storyboard files and images and all of this and the code that makes it work, and wrap it up into a framework, or even just have a couple of view controllers put into a framework and then be able to package those and import them elsewhere separately. So that's really cool. I should have started with the intro though. So one framework that you'll use all the time is the foundation framework. That's why it's called foundation. It defines the foundation for everything on iOS, but it's meant to be something that's beneath even the concept of an app or anything, right? It's the lowest level. It has just primitive things like string, numbers, arrays, dictionaries, like your common data structures and types you might want to work with, dates and date logic, things like that. And pretty much, well, not pretty much, every other framework is going to build on top of Foundation and use those things. I mean, have you ever written an app and not used a string or an array or some kind of data type? Probably not. So Foundation holds all of that. It's an Objective-C framework. So at least when you're using it in Objective-C, you're going to see that NS prefix in front of all of the class names. That comes from NextStep, part of Apple history, the other company NextStep, that's NS. When you import Foundation bridge types into Swift, now in our modern era, they just represent themselves instead of NS string as just the string. You can use the Swift bridge type, which is, it's worth reading more into, but you can think of it effectively as the same thing, bridged into pretty Swift land. Next, another framework that of course we all know is UIKit, what we just talked about, that builds on top of Foundation. That has all of your code with the UI prefix, UI view controller, UI table view, button, switch, navigation item, etc. And then a good example of, okay, well, what other types of frameworks are there would be the brand new ARKit framework. I guess it's not quite brand new anymore. I notice it has all of the AR class prefixes. Um, and this is going to handle all AR related functionality, right? Things like all the classes that manage ARKit functionality. And I don't remember exactly what kind of hooks there are between UIKit and ARKit, but I know that there are even pieces of the frameworks that are meant to interoperate with each other to work well, such that it's not too hard to take something like an AR scene, I think it is, and drop it right into a UI view, things like that. So, of course, that's what's great about these Apple frameworks is they're all developed together and with each other in mind, and with the purpose of take these technologies and eventually do something with them that the user can see or interact with or be affected by, right? And that is why they're all going to work nicely together. Languages, I mentioned Objective-C and Swift. Apple's been using Objective-C for its 20, 30, whatever years of being around. Swift is only new as of, 2014, only, wow, 6 years ago. So Objective-C is a superset of C. That means anything you could compile in C, you can also compile in Objective-C. Objective-C just adds a bunch of things on top, specifically object-oriented features, so that you can have things like classes and protocols, which are like Java interfaces, and all of that. Things like dynamic method binding, right? It is a super dynamic framework, which is perhaps one of its problems, actually. It's kind of, I won't say legacy isn't quite the right term now because it is of course, still around. 90 whatever percent of all of Apple's platforms are still written in Objective-C. It's just legacy in the sense that there is this brand new thing that has many, many advantages over it as it is evolving, which is Swift. Swift is new, fun, and fast. I read about Swift's performance earlier today, and it takes advantage of a ton of modern ways of modern compiler infrastructures and things that couldn't be backwards made possible into things like C and Objective-C, but that now, since Swift was just built from the ground up, can take advantage of. It can be up to, apparently, as Apple claims, up to 2.6 times as fast as Objective-C. It's super comparable to C++ in terms of speed. What else about Swift performance there? It's pretty great. It's pretty fast, and it's super safe, reliable, easy, easy to keep well kept as well, which makes it super great. Awesome. Putting it all together. So if you take this whole overview and wrap it up, that means basically you're going to create an app using Xcode in either Swift, Objective-C, or both. That's a thing. But probably Swift, especially for iOS Club, we do all of our examples in Swift because it's the new and great thing. You're going to build this app utilizing the UIKit framework and other frameworks to build your app. Those other frameworks might be the things that add, special functionality on top that aren't just core to UIKit's logic, right? So maybe every app needs buttons and views and pretty animated things. That's in UIKit, but as soon as you need to add AR, you're going to want to use ARKit. Things like location management. There's a framework called Core Location that manages that. Do some complex data saving, and now you're using core data, right? So there are other frameworks that you build into your app to encompass more technologies. Test your app using the iOS simulator or on a real device. And then finally, when you're all done, you're going to upload and distribute that app in App Store Connect. Of course, you want to go look that up separately. Awesome. There's more resources on developer.apple.com. Great, so now let's just take a look quickly at, we're going to talk about Swift. Here's our Swift overview. And the only thing I'm going to mention before showing some examples is here's Swift versus Objective-C and their performance. So there we go. Check that out. Those are some different metrics. You can find these graphics all over the internet. Anyways, let's go back to, here we are in Xcode. We're going to take a single view app. I'm basically just going to make this app just so we can look at some Swift syntax and things like that. And the main thing we're going to talk about today is optionals as a new concept, because I think pretty much every other introductory tutorial that we have is going to cover Swift and all of those kinds of things from a write a function, run some code standpoint. So let's just Swift fun. Here we go. Cool. Swift storyboard. Look, now they have, yeah, Swift Objective-C. Swift UI is a new thing. Okay. Let's just do that. Taking our time today. Got too many things open. Okay. Great. So I'm just going to use this view controller, or even probably make another couple of files to show some examples of just how Swift is kind of put together. So if you look at starting from here, this is an import of the UIKit framework, right? This is a framework that's getting imported into Swift. You should keep in mind that whereas in Objective-C frameworks, they get a namespace from their class prefix like that, which is UI for UIKit. That's why we have UI view controller. When you make your own classes inside of your own app, those are getting namespaced by your app's name. So let's, for example, create a new file. I don't know. I'm going to use a really cliche example. Let's pretend that we were creating a playing cards or a Texas Hold'em poker kind of app, something like that. So we needed to have like a playing card struct or class or something. And I'll just throw that in there. Notice I have playing card.swift. It imports foundation by default. And if I make something like a playing card, now I have this, which I might want to reference somewhere else. Let's pretend that this view controller is going to hold, this is a terrible example, but a bunch of playing cards to display or something, right? I don't know. Playing. Notice I could just define this by the playing card type. I could also, I'm pretty sure, yeah, namespace it with Swift fun.playing card. Just like that. So if I go to try to build this, my B key doesn't want to work. Here we go. Check that out. So that's just an example of how the namespacing with modules works in Swift. So I'm actually, I mess up the terminology, but the point being, when Swift is compiling your code, it's namespacing it as part of a module, which I think in this case the app is just the module. But if you had a separate framework that was a Swift framework, it would be namespaced by the name of that framework, right? So whereas if I instead try to add some kind of little UI view in here, I can do UIKit.UI view, and we also have that basically made up Swift package that was the Objective-C version and still the Objective-C prefix. But when we're just inside of a Swift framework, we just use this name of our module and then the class type. Okay, what else do we want to talk about? So that's just looking at modules and types and names and things in Swift. Hopefully we've all seen things like let declaration. Oh, I can't type. Versus a variable declaration, something type like number of button. Right, so now I can't reassign to a let because it's already been defined. That's not going to work, right? But I could add some kind of function, from a button and connect it, blah, 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 where I said number of taps, because that's a variable declaration. Oh, I don't know why I did that. Cool. And this would work. Awesome. Now I'm going to jump into our Swift optionals presentation so we can briefly talk about optionals in Swift, which are what make it really interesting. Okay. So back here, optionals in Swift. Okay, yeah, as we just mentioned, right? We have declare Swift variables or constants. Let is for constants. Var is for variables that will change. We just saw that example. And now that we know that, we can just start typing. Just do what feels natural in Swift, and it'll probably be correct. There's a type inference, as you can see. So if we just say let name equals will, it's going to infer the type to be of type string. Whereas I could have said, there's the type inference, let name equals Cliff. I could say let name of type string equal Cliff. Either way works in Swift. If it can infer the type, it's just going to do it by default. Okay, cool. What are optionals though? So, well, let's see why we might need an optional. Normally in Java, you could just say name equals Cliff, right? Or maybe you could say, string name equals null, in something like Java. In Swift, we have nil. Notice I'm gonna have to give Swift the type anyways, right? Because it has nothing over here. But if I say let name of type string equals nil, that might look okay. And you're saying, okay, there's no value right now, but we know it's of type string, so you can give it a value later. Maybe give it a variable type so that we can assign something to it later. That does not actually work in Swift. Look what it wants us to do. It says you can't assign nil to the type string. You have to make it of type string optional. Read that as string optional or optional string. I think convention is string optional. And what that means is, well, if we look at, we won't do that now. This optional type can basically contain one of two values. Either an actual real non-nil value of the type that it wraps, or a nil, right? So whereas in most languages, C included, you can have maybe a char pointer or something that points towards a char or towards null, and you don't know until you go to check the value. In Swift, you basically define with the type declaration whether this has to contain a value or not. So here we are saying that this name is of type string optional, so it might contain nil and it might contain an actual string. But if I say let name equal, or name2, Cliff, you don't have to do any checking later, and the language won't let you for checking to see if name2 is null or doesn't contain a value or is nil, whatever, right? It's not possible because we've told it can only be of type string. So this is really useful, this concept of knowing when you have to have a value versus when there might not be one. This is going to help you avoid a ton of pitfalls from Java, like with null pointer exceptions, and from Objective-C, where a null would turn into a no-op that you didn't want to. Okay, so yeah, an optional is a wrapper container object. I think, oh God, is it actually? I think it's just an enum built into the Swift language with some syntax sugar that is basically just wrapping. It's a generic type that's going to wrap whatever type you put into it. So like I said, string optional, it's basically just an optional genericized to string. So it can either contain a string non-optional, a string, or nil, right? Optionals are the only values that can be nil in Swift. Awesome. Here we go. So there's let college of type string. If you declare that as part of a class, then in your initializer, you're going to have to assign it a value during init so that it always has a value by the time the object is fully initialized, and you will never be able to, you can't change it again because it is let. But even if this was var college of type string, you couldn't ever assign it to be nil later. That will never work. It can never be nil. The compiler is enforcing that. Versus if you have some kind of type, locally in a function or as an instance member, graduation year of type int optional, well, maybe we make this optional because it actually has meaning that there either could be a value or not. Maybe how you define someone's graduation status is, or academic record, is you give them a graduation year that's non-nil. Maybe it's 2020, and that means, okay, they actually graduated in 2020. And maybe you define, just semantically, that if it's a type nil, then they haven't graduated yet, right? Like there's no value, and maybe that you don't want to do this whole semantic thing of, oh, let's just say if they haven't graduated, give them -1. You want to actually have like a compiler helping way of you determining should there be a value here or not. I can think of much better ways to represent, have you graduated or not, just from an int optional. But this is one example, right, where you want to actually show this concept that this variable can have a value and it might not. Okay, so here's one way that you could use this optional graduation year, right? You might need to check if graduation year is not nil, then okay, when you're graduating or when you graduated. That's great. And here's how you could simultaneously check to see if the value is not nil, aka if the variable graduation year contains a value, contains an int, and simultaneously, if it does, assign that value, that int, to the local variable year that will then be of type non-nil int, like just int, inside of the scope of that if let. So Swift calls this a, oh my gosh, I can't remember. We're gonna have to Google it later. There's an actual word in the Swift language guide all over it that I just can't remember. That is when you simultaneously conditionally unwrap an optional. Unwrapping an optional means give me the value in the optional if one exists. Is this called the something unwrapping assignment or something like that? The point is you are simultaneously unwrapping the value from the graduation year optional if it exists and assigning it to the variable year. And if graduation year is nil in that lower case, then the if is just going to execute to false and resume execution afterwards. This is what we call a safe unwrap. You are not doing some kind of ugly if not nil check and then force unwrapping it later or doing something weird. You are checking to see if there's a value, and if there is, assigning it to a variable that you can now use immediately. And that's all we've got for that. Cool. So the last thing I'll talk about for optionals in Swift, to kind of just connect a couple things back to what we know to be the case from programming our apps, is a lot of the time when you connect an interface builder outlet, you'll see at IB outlet, weak private var, I don't know, some button, right? And it's of type UI button. UI button. Great. Notice you may have seen before this exclamation point, and now we're going to bring it full circle and answer the question, what is that? This is the force optional unwrap operator. It will either or it's also called the implicitly or the implicit unwrapping operator declaration. So the point being, let's pretend we have this name of type string optional equals nil. Normally I'd want to say something like if let, you can say if let name equals name, print name. That's the local non-optional string name. See the connection there versus these two. The other way to do that is, let's pretend that you are really doing something nasty, and you, instead of safely unwrapping it and checking it, you really need that value to be not nil. You could just say print name and use this operator. That is going to force unwrap the optional here, and if it contains a value, it'll work just fine. No need for this if let stuff. But if it does not contain a value, if it is nil, this is the exact same thing as your null pointer crash in Java. You're going to get a crash that says like found nil while unwrapping optional value, or unexpectedly found nil while force unwrapping optional value, whatever, name. So that's what that means. However, this is useful at times when you know for a fact that there is a value in an optional variable type, but you don't want to do all of this extra syntax here, so it's safe to force unwrap it, right? There are plenty of cases where that is true, and one of those is interface builder outlet connections. So because this connection is made, and what I mean by that is this variable is assigned the actual UI button value after the, type init of view controller. Um, what I mean by that is in the lifecycle of this object, view controller is first instantiated, but button is not assigned a value during init for this class. And because of that, we can't make this a non-nil type, because if this was, even though we know it's going to get assigned later, if we wanted this to be non-nil as part of its member declaration, it would have to be assigned a value during init. But that's not the case with how the view controller lifecycle works. Instances of view controllers are instantiated first, and not very much interesting happens during init. What all happens later that's useful is the view loading process, right? So this isn't going to be assigned a value until the load view function in UI view controller. You definitely want to call super.loadView if you ever override this. This function is what's responsible for taking or decoding your entire, the rest of your storyboard, and connecting, instantiating all of those members, like all of the buttons, and actually assigning them to the instance variables as part of this class, right? So that's not happening until after init. But my point is, because this value can't be non-optional, because Swift won't let us make an optional value that we don't assign an actual value to during the object's init method, during initialization, but we know for a fact that it's going to be non-nil by the time we want to use it later at any point. We declare this as not type UI button optional, but instead UI button implicitly unwrapped optional. And that means it gives you that free pass where you don't have to assign it a value during init, and you don't have to unwrap it when you go to try to use it. So I don't have to later say if let actual I don't have to do this. I just want to access self.button.background color, right? And I don't want to have this in here. You can do that when you declare this type to be implicitly unwrapped, because it is basically implicitly inserting a force unwrap operator in every time you use it. And it's actually just a nil behind the scenes, or an optional type behind the scenes. So that's really useful, because we know, although it can't be a non-optional type because of it's not being initialized during init, but we know it's going to be assigned a value every time we try to use it, because it's going to be assigned a value in load view before we ever do anything in our view lifecycle. Instead, all interface builder connections by default are declared implicitly unwrapped, meaning, great, they don't have to be initialized, but then when I go to use it later, I don't need any extra operators. I can treat it just like I would treat any non-nil or non-optional value, just like that. I know that's super complicated. I recommend reading the Swift language guide a little bit in the optional section more. I hope this little overview helped. And as always, best luck in all of your coding adventures. And thank you for listening. Bye-bye.